All right, so if we change the less than to greater than, it actually becomes a slightly more interesting problem. I want to know where the graph of x squared is above the graph of the natural log of x plus 2. Now, think about the graph of the natural log of x plus 2. Where is the vertical asymptote for this function? At x equals -2. Very good. Yeah, because it's normally at x equals 0, the y-axis, and the plus 2 shifts it to the left 2 units. So remember what I told you yesterday. Get everything on one side, and now it's greater than or equal to 0. We'll graph this in y1, which gives us a single curve instead of looking to see where two curves intersect. And then, of course, we'll graph the x-axis in y2. So we can use the intersection command of the calculator rather than the 0 command. It's a little bit faster. So I type it in into y1, and then to y2 I put 0, and then I hit zoom 6, which is your standard window. So I want to know where it's greater than 0. I want to know where it's above, don't I? So there's 2 points of intersection. Let's go ahead and find the points of intersection. Points of intersection. And again, I'm labeling what I'm doing so that there's no doubt. Okay. So I get x equals second trace number 5, enter, 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 which is why we use intersection instead of 0. There's not scrolling. There's no scrolling. -0.711. If you needed to store that, you could store that as A, because we're about to find another one. I'm not going to store it. Second trace number 5, enter, enter. This time we can scroll a little bit closer to the one we want. Still faster than using the 0 command. And I get 1.600 if I truncate, right? And I need those 2 zeros. So now how do I use those x-intercepts to answer the question? I want to know where it's greater than 0. That's above the x-axis. So I know it's going to be for all values of x that are greater than 1.600. Would you agree? But can I just say it's also for all x less than 0.0711? Everywhere to the left?
No.
No. The graph on the right continues to go up as it goes out to the right forever and ever and ever. But does the graph on the left continue to go to the left forever and ever and ever? There's a vertical asymptote at -2. So we better stay to the right of -2. So this could be your answer, or you can write it as x epsilon, parentheses, -2 to -0.711, union 1.600 to infinity. Okay, very important to realize that the graph has a vertical asymptote at -2, because your calculator doesn't draw vertical asymptotes, does it? If you notice, the graph does kind of look like it's going up very, very steeply. Now, you can maybe appreciate what's going on. Instead of looking from -10 to 10, what if you look from -100, or actually, let's go negative, we don't need to go to -100. Let's go -5 to 100. And I hit graph. Let's make the window taller too. Let's go to 1,000. There you go. So you see, you can't see the vertical part on the left anymore because we stretched out the horizontal scale. It goes vertically so steeply. But you can see that the graph, as we go out to the right, continues to go up forever and ever as it goes out to the right forever and ever. See that? Okay. If you also did this, if you hit trace and you typed in -3, you're not going to get any answer. It doesn't give you a y value because it doesn't go to the left of -2. Y values are empty. Okay, you have to know that coming in. Questions on the warm-up? Are y'all warm? All right. Let's see if we can finish the notes here. We got 3 examples to go. We can do it. Find the x and y intercepts of the following, and then sketch the graphs. Okay, I'm going to sketch the graphs first, okay, before I find the x and y intercepts. I want to put it into standard transformation form, STF. It's, oh, no, nombre. Oh, I did example C. But I changed it to greater than. So I did that from the notes. Okay, yeah. It's a more interesting problem when it's greater than. All right, example 9. So all I need to do is make the inside match. So that's -x plus 3 plus 7. And then on the inside, remember, I need to factor out the negative, so that gives me x minus 3 plus 7. Okay, now the parent function is natural log. We know what that looks like. What does the negative do in front of the x? Here's what the natural log of x looks like. What does the negative in front of the x do to that graph? reflects it across the y-axis. So now it moves to the left of the vertical asymptote and it's decreasing. What does the minus 3 do? Moves it right 3. So the vertical asymptote, which was at 0, is now where? At 3. So I'm going to draw my new vertical asymptote. And the plus 7 just moves it up 7, doesn't it? So that doesn't really, that just moves it vertically. So my final graph is going to be this. Now I have it crossing in positive land. If I need to move it, I will. If I need to move it up or down, I will. We're going to find the x and y intercepts. In general, which of those two is easier to find, the x or the y intercept? Ooh, no. The y-intercept is easier because all you got to do is let x equal 0. And it's a function of x, so it's just plug and chug, right? The y-intercept is just plug and chug. So here we go. Y of 0, you can write it like a function notation, is equal to the natural log of, what's 3 minus 0? 3 plus 7. Is that a positive number? Yeah, that's a positive number. Because the natural log of e is 1, right? So the natural log of 3 is a little bit bigger than 1. So I have it crossing in positive land. That looks good. So this would be the exact answer right here. Y of 0 is the natural log of 3 plus 7. So I don't have to move my graph up or down. It looks good. Now, the x-intercept, this is what we normally couldn't find unless we had a calculator. I want to know where it crosses the x-axis. My graph happens to cross directly at 2. I'm not going to take off if you have it crossing at 2 and it actually crosses at like 2.2. As long as you have a crossing in positive land, which it should, it crosses somewhere between 0 and 3. How do we find x-intercepts? They're the more challenging of the two. We let y or f of x equal 0. That means we set the whole thing equal to 0. So let's do that. Now I'm going to use the original version of it because the standard transformation form is only useful for graphing and maybe a couple of other things, but not for solving. We don't want all those extra parentheses. Now we have the algebraic skills to solve for x, right? What's the first thing we're going to do? Subtract the 7. So I get negative 7. Now how do I unlog natural log both sides? Base e. We exponentiate both sides base e. Very good. And on the left, what's e to the natural log of blob? Blob. And we get e to the negative 7th. Now remember, e to the negative 7th is the same as 1 over e to the 7th. It's not a negative number. It's a very small positive number. All right, so I'm going to bring the 3 across, and I get negative 3 plus e to the negative 7th. And if I multiply it through by a negative, I get x equals positive 3 minus e to the negative 7th. Which really, if you want to appreciate that, that's 3 minus 1 over e to the 7th. It's very, very small, right? So this is approximately 2 point, maybe even like 9 something. I don't know. Let's see. Let's go to the calculator. 3 minus e, second ln, to the negative 7th. Yeah, look at that, 2.999088118. So I have it crossing at 2. It actually hugs it goes vertically almost, and just to the left of the vertical asymptote, it crosses the x-axis. Okay, so this would be the answer. That's the x-intercept. Previously, we would have to find that using the calculator. Okay, graphing 0 and looking for the x-intercept like we just did on the warm-up. But now we can find the exact answer. Pretty cool, huh? We know the algebraic skills. All right, the next one. Y equals 4 times 7 to the x minus 3. What's your parent function here? 7 to the x? Yeah. And that's exponential growth or decay? It's exponential growth. So it has a horizontal asymptote on the x-axis, and it looks something like this. All right, so there's your parent function. What does the 4 do? Vertical stretch by a factor of 4. Does that change the shape? It just makes it a little bit steeper, right? So I'm not going to show that. But what does the minus 3 do? Down 3. And that's important because that moves the horizontal asymptote, which used to be at 0. Okay. Now, if I draw my function, I'm going to draw it like this. And I have it currently crossing the y-axis in negative land. Okay, and I have it crossing the x-axis in positive land. Let's see if that's actually true. Which of the two is easier to find, the x or the y-intercept? Y-intercept. So let's label it y-intercept, and we'll do y of 0. That's like function notation. And we get 4 to the, what's 7 to the 0 power? 1 minus 3, which is 1. Is my graph correct?
No.
Holy moly. If you leave it like that, you're going to lose points. So let me redraw it. It actually it goes steeper like this. Okay, it goes like that. So now my x-intercept should be some negative number, shouldn't it? Instead of a positive number. All right. Let's find the x-intercept now. For the x-intercept, we're going to set the whole thing equal to 0. 4 times 7 to the x minus 3. We set it equal to 0. Now we're solving an exponential equation, which again, previous to this section, we'd have to find the decimal by graphing 0 and finding the x-intercept. Not anymore. We can now find the exact value. We'll add 3 to both sides. We'll divide through by 4. And now how do we un-exponentiate base 7? Yeah, you can log at base 7, or what did we do? We natural logged it, didn't we? What would you be more inclined to do? Logging at base 7 or natural logging it? I don't really care. If you log at base 7, you'll just use the change of base formula at the end. Let's take the natural log of both sides. That's kind of what we did in class. So we'll take the natural log of 7 to the x equals the natural log of 3/4. Natural log both sides. Now, that allows the x to come out front, which gets it out of the exponent land. And then natural log of 7 is just a number. So my final answer could be the natural log of 3/4 all over the natural log of 7. That's the x-intercept. And that should be a negative number, which it is, because the natural log of 1, remember, is 0. So the natural log of 3/4 should be a negative number. What's that? Did you use log base 7? I mean, yeah, we could. We can call that log base 7 of 3/4. Yeah? Remember what I told you to do after you got your answer with logs? Play. Yeah. So you could call that log base 7 of 3/4. Might I call it log base 7 of 3/4 on the test as an answer choice? Maybe. What else could I do in the top? I can call that the natural log of 3 minus the natural log of 4 over the natural log of 7. I would be more inclined to do that. Expand the numerator because there's a quotient. Now, what else could I do with the 4? 4 is not prime, is it?
You can do 2 squared.
I could do 2 squared and then bring the 2 where? Out front, which would make it 2 natural log of 2. That's a nice way to write it as well, too, isn't it? Now, all of those are going to be negative numbers. I know that from my graph because my y-intercept was positive. And I also know the natural log of 3/4 is a negative number. All right, so yeah, as an answer choice on a free response, I would take any one of those as a free response answer. But as a multiple choice answer, only one of those would be an answer choice. And then you'd have like 4 others that are wrong, that are tempting. Oh, so tempting. Let's see what it actually equals. Let's do the natural log of 0.75 divided by the natural log of 7, if you're curious. Yeah, it's negative 0.147. Okay, so it crosses right there in negative land. Now that's important because remember when I drew it at first, I had a negative y-intercept and a positive x-intercept, but the numbers actually corrected my graph, and now I have a more accurate depiction of it. All right, everyone good with finding x and y intercepts? We now have the algebraic skills to do it. We solve log equations or exponential equations, depending on what we're doing. All right, very similarly now, we're going to find inverse functions. Remember how you find inverse functions? You swap x and y and resolve for y. That's our goal here. We're going to swap x and y, and then we're going to resolve for y. That's how you do it for any equation, right? So remember, f of x is just a fancy name for what letter? Y. So I'm going to do green, the money step. Cha-ching. We switch x and y. So we get x equals 5 to the y minus 4th plus 3. Now, before we start, the function here is an exponential function, base 5. What type of function do you suspect the inverse will be?
Natural log.
It could be a natural log function, or if we keep it pure, it could be a log function based what also? 5. Yeah, it should be a log base 5. If you have an exponential base 5, your inverse could be a log base 5, which of course we can write in terms of ln. All right, the first thing we would do is subtract the 3. It's almost like finding the x and y intercepts over there, except we're doing it with variables. So we have 5 to the y minus 4. And now how do we unlog it base 5? Or exponentiate it base 5? Yeah, let's go ahead and log it base 5. So I get log base 5 of x minus 3 equals log base 5 of y minus 4. Now you could also take the natural log of it if you want, like we did in the previous problem. Um, oops, I didn't do my right side correctly. I was thinking about what I was going to say instead. Okay, so there we go. Now we get log base 5 of x minus 3 on the left. And what happens on the right-hand side? What is log base 5 of 5 to the blob? We get the blob, y minus 4. And then the last thing we have to do is add 4 to both sides. So we get y equals log base 5 of x minus 3 plus 4. And of course, we solve for y. So the last thing we do is we elevate its name. Instead of calling it plain old y, since the original function was f, we'll call this one f inverse. And we get log base 5 of x minus 3 plus 4. So if it's a question on the test and we're trying to find an inverse function, I would more likely keep it as a same base, like a log base 5 instead of an ln. But if the answer choices happen to be in terms of ln, we'll just use the change of base formula on the log part. That's the natural log of x minus 3 over the natural log of 5 plus 4. They're the same, right? These are exactly the same. And if you would have taken the natural log to begin with, you would have ended up with the bottom line, which then you can condense back down to log base 5 using the change of base formula. Same skill set, right? We're just solving using logs or solving using exponential. All right, let's do this one. We're starting with a log base 5, so our inverse now should end up being what? No, if it starts, no, it starts as a log, so it should end up as a what? Exponential. Yeah, logs and exponentials are inverses. So now we're starting with a log base 5. Now we should end up with an exponential base 5. And we're going to leave it in terms of base 5. We're not going to write it in terms of e. So g of x is just a fancy name for y. So we'll interchange it. Here's the money step. X equals log base 5 of 6y plus 4 minus 3. All right, I got to peel back the layers and get at the y. What's the first thing I do? Add 3. So I get x plus 3 equals log base 5 of 6y plus 4. And now I'm faced with the log, so how do I unlog it base 5? Exponentiate base 5. So I get 5 to the x plus 3 on the left. And of course, what happens over here? 5 to the log base 5 of blob is just the blob, 6y plus 4. And now we're back in algebra 1. I'll subtract 4 from both sides, so I get 5 to the x plus 3 minus 4 equals 6y. And then how do I solve for y? Divide by 6. So I get 5 to the x plus 3 minus 4, all divided by 6. Now I'm going to do two things. The first thing I'm going to do is call that g inverse of x, give it a new name, and then instead of dividing by 6, it's like multiplying by 1/6. So that'll be a 1/6 times 5 to the x plus 3 minus 4 over 6. Distribute the 6. Now, what happens to the minus 4 over 6? It becomes 2/3, yeah. So if we were doing this on a test, this would probably be the multiple choice answer. Because now I don't have it all over 6. I have it as 2 terms. It's in standard transformation form. Same skill set, right? We're just using logs to solve exponentials and exponentials to solve logs. We just did it with variables there instead of numbers like we did on the x and y intercept problem. All right, now we're stepping it up another notch. Instead of just having one variable or two variables, x and y, we're going to have lots of variables. These are called literal equations. Another name for a literal equation is a formula. Okay? They're the same things. The formula is just an equation that has lots of variables in it, And you can use the formula as long as you plug in enough information to find the single unknown quantity. So if you calculate how many unknown quantities we have here, let's count them. We have t, t sub s, d sub o, and we have k, and we have t. How many unknowns do we have? 5 unknowns.
Wouldn't the T be the same though?
Would the t be the same?
So that
No, no, because this is typically what they do in science class. Like T is different from T sub S. T sub S would be like the start. Let's say T is temperature. T would be the temperature at any given time for little t, and big T sub S might be the starting temperature. Okay,
okay.
that's like D sub. Sometimes we use D sub O to differentiate from D. D might be like the starting dinero, and D might be the dinero at any given time.
So the T and the exponent and what T is equal to are two different.
Yes, a bit in a formula, a capital letter and a lowercase letter are different. Okay, yeah. So T is different from T sub S. They're both capital, but one has a subscript, so they're different from each other. And little t is a lowercase t, so it's something else. Big T might be temperature, little t might be time, and T sub S might be a fixed starting temperature. Okay, I don't really know what this equation is for. I think I just made it up. But the point is we can manipulate these variables around just like we do up above when we have numbers, okay? Sometimes I have a formula and I want to solve it for a particular variable to get what's called a working equation, all right? Now you can either plug in all your numbers, and you got to know 4 of them here. If you're going to use this formula correctly, you have to know 4 of the 5 unknowns so you can solve for the 5th unknown. Some people like to plug in and then solve, but we should be able to solve and then plug in, which is what we're going to do here. So if I want to solve for t, that's this guy right here. What would be the first thing I would need to do? Subtract t sub s, right? It's a constant. So I get t minus t sub s equals d sub o times e to the negative k times t. All right. Now what do I need to do? I'm trying to get at the little t, so I need to get rid of the d sub o. Divide. So I get t minus t sub s divided by d sub o equals e to the negative kt power. I'm getting closer. I'm peeling back the layers, getting at the t. Now I have to un-e something. How do I un-e something? Now natural log it. So I get the natural log of t minus t sub s over d sub o. And I'm not even going to write the natural log of e to the blob. I'm just going to put the blob. It's negative kt. And now I'm almost there. How do I solve for t? Divide by negative k. So I get the natural log of t minus t sub s all over d sub o. And be careful. The d sub o is part of the argument. I almost slipped there. And all of that is over negative k. Now here's another way to write it, which I would probably do on a test. Negative 1 over k, right? Dividing by k is the same as multiplying by its reciprocal. And what that does is it tames it a little bit so we don't have a complex fraction. There it is. So if big T was temperature, the original formula was set up to find the temperature at any given time if you know all the other variables. Now we've solved it for T, so we've kind of created a new equation, what's called a working equation, which now allows us to find the time if we know all the other variables. Okay? So you do this in your science class quite a bit, physics or whatever. You manipulate formulas. It's just the same skill set, we're just using letters instead of numbers. All right, now we've already done one like this. We want to solve this one for x. So we have a, b. Remember, e is not a variable. E is 2.718. And then we got x, c, and d. So 1, 2, 3, we have 5 unknowns here again. And we're trying to solve for x. Peel back those layers. What would we do first if x is in the denominator? Multiply both sides by the denominator. So I'm going to get y times the quantity, 1 plus b e to the negative x minus c divided by dth power equals a. Now you have two options here. You're at a fork in the road. And if these were numbers, we would probably be informed in what to do. I can either A, distribute the y into both terms. Would y'all see that? Okay. Or you could divide both sides by y and get a over y on the right-hand side, which generates a fraction. Okay. If these were numbers instead of variables, I would probably look to see what we could do. Like if y were 10 and a were 100, would you divide both sides by 10? Yeah, because 100 divided by 10 is 10. But what if this were on the left side? What if it were, instead of a 10, what if it were 11? Would you divide both sides by 11? Probably not, because now you're carrying around 111ths, which doesn't work. So with numbers, we can inform ourselves what to do a little bit more wisely. But we do have a fork in the road here, and I'm going to let you tell me what to do. I don't care. We're going to have fractions anyway, because we have one in the exponent already. What do you want to do? You want to distribute the y or divide by y? Divide by y? Okay, that's probably what I would do. That leaves fewer variables. Notice when you distribute the y, you're going to end up with a y in two different terms. So if I divide by y, I get 1 plus be to the negative x minus c over d power. I wrote it without the parentheses because I wrote a vinculum horizontal instead of a stylus. I get a over y. A. All right. Now I'm trying to get at the x. Don't lose your target. There's your x. What do I need to do now to isolate the variable term? Subtract 1. So I get be to the negative x minus c over d equals a minus 1. And now how do I get rid of the b that's in front of the e? Divide by b. Okay, so I get e to the negative x minus c all over d equals a over y minus 1 all over b. Now, I don't really like complex fractions, do you? No. So what I'm going to do now is I'm going to multiply by the reciprocal instead and distribute it. When I distribute the 1 over b to both terms, I get a over by minus 1 over b. That works the same way. Now I don't have a complex fraction. 1 over b times a over y is 1 over a over by, and then 1 over b times 1 is 1 over b. All right, now I can un-e both sides. Here's the new skill that we learned in this section. How do we un-e both sides? Natural log. So I get negative x minus c all over d equals the natural log of the quantity a over by minus 1 over b. I'm getting there. Persistence will pay off. Now what? I have a fraction on the left, and I'm trying to get at one of the terms in the numerator. Multiply both sides by d. Good. So I get negative x minus c equals d times the natural log of a over by minus 1 over b. I'm getting there. Now what? If you add x, it'll become positive on the right, which is fine, but then you're going to have to do what with the d natural log of blah? We're solving for x. That's our goal. So I want it to be on the left ultimately. Let's just add c to both sides. Yeah, let's add c. So I get negative x equals d natural log of the quantity a over by minus 1 over b plus c. And then the last step, divide by negative 1 or multiply by negative 1, either one. Now I'm going to distribute the negative 1 on the right-hand side. So I get x equals negative d natural log of a over by minus 1 over b, and then minus c. And there it is. We just manipulated a bunch of symbols using the rules of PEMDAS, which now have this new rung on the top of our ladder, right? Above exponentiation, well, with exponentiation, we have logging and exponentiation. Exponentiation and logging. No, because I distributed the negative. If you multiply both sides by negative 1 and you have two terms on the right, you would distribute it. If you wanted to keep it positive c, Brady, you could put parentheses here and put a plus sign there, right? And then distribute the negative to both terms. But in general, I don't like the parentheses in terms of simplified, so I distributed it. Great question, though. You don't want to mess up right there at the very end, do you? Oh, my gosh. Yeah, all of that. So that's solving a literal equation or a formula. You got the skills, okay? You got the skills. So your homework is due mañana, which is Wednesday, January 24th. 24. Look at that. 120. Ooh, 124.24. That'll never happen for another 100 years. Okay. At 9 a.m. 9 a.m. It's late after 9 a.m. and you have to print it out. Some of y'all know about printing out. Um, in class tomorrow. So Wednesday in class, I already put it in the Canvas. You're going to work an old test. And I put the key in there too. So it's just for your benefit. Pay attention tomorrow, and I'll remind you tomorrow, you want to pay attention to the multiple choice questions particularly. Because the free response on the test that you're working tomorrow is a word problem, which is good. A word problem is just using a log equation to answer questions. But I changed your free response question for your test on Thursday. Thursday, you'll have a test over all of chapter 4. I changed the free response from a single word problem with multiple parts to several smaller single problems like multiple choice questions, but short answer. Just like any of these. Any of these questions that we worked today could be one of your free response questions. Solving a log equation by condensing, solving an exponential equation by getting the bases the same, finding the inverse of a function, finding the y-intercept. Okay, so your Thursday test won't have a single free response question. And there's no calculator. So I'm not going to ask you to do anything like the warm-up. Okay, it's all it's all made by hand. It's an artisan test. Okay, all your answers will be exact answers. All right, we got 14 minutes in class. If you want to work on your homework, you got time. I'm here to answer any questions you might have. Are there any right now? Yeah. Okay, let me exit the recording here. Have a good rest of your Tuesday.